All right, let's jump right in. Today we are tackling a really fundamental question that gets to the heart of how our digital world works. What's the real difference between a blockchain and a traditional database? You know, the kind that's been running things behind the scenes for decades. This is going to be fun. Let's do it. Think about it. Pretty much everything we do online, from sending money to liking a photo, it all relies on data. But how do we know for sure that data is legit, that it hasn't been secretly changed? How do we build trust, especially when you have a bunch of different people or companies who don't necessarily trust each other? Honestly, this one question is the key to understanding everything we're about to cover.
For a long time, the answer to that trust problem was simple. You put one person or one company in charge. You have a centralized database. And look, it's a powerful and super efficient model. But now, a challenger has entered the ring with a totally different idea about how we should manage, and more importantly, how we should trust our data.
So, let's start with the reigning champ, the traditional database. To really get why it's been so dominant for so long, we need to talk about something called the acid test.
Okay, so at its core, a traditional database is just a highly organized system. The easiest way to picture it is like a set of spreadsheets with neat tables, rows, and columns. But the most crucial part is that it's almost always centralized. There's a single administrator, a single gatekeeper, who holds all the keys. That central control is its defining feature.
So, what makes these things so rock solid? Well, they pass the ACD test. Atomicity is the all-or-nothing rule. A wire transfer can't have money leave your account without it arriving in the other one. That's just not allowed. Consistency means that the database's own rules are never, ever broken. Isolation means that if 100 transactions are happening at once, they don't mess each other up. And durability, well, that's simple. Once a change is saved, it is saved, even if the server crashes a second later. This has been the gold standard for reliability for decades.
And this model has huge strengths, for sure. It's incredibly fast, it's efficient, and we've had decades to perfect it. But that central control, that's also its Achilles heel. It creates a single point of failure. If that central server goes down, the whole show stops. And maybe even more importantly, it means you have to put 100% of your trust in that administrator not to mess up, or, not to maliciously go in and change things.
And that is the perfect setup for our challenger, blockchain. If traditional databases live and die by the acid test, blockchain brings a whole new philosophy to the table. Get ready for the SALT alternative.
Yep, that's right. And it's not just a clever acronym. SALT is a framework that perfectly describes the unique DNA of a blockchain transaction. It's a completely new way of thinking about how data should work.
First up, S is for sequential. This just means that on a blockchain, every transaction is processed in a strict one-after-the-other order. There's no parallel processing like you might find in a traditional database. Everything gets in line, creating a single, undeniable history of what happened and when.
Next, A for agreed. Now, this is a huge change. There's no central boss here. A transaction is only added to the record if the community, the majority of computers on the network, all collectively agree that it's valid. This is that idea of consensus you hear about all the time.
Then we have L for ledgered. Once the network agrees on a transaction, it's permanently recorded in this shared digital book, this ledger. And the key thing is it's append-only. That means you can only add new pages. You can't go back and rip out old ones or scribble over the past. It's an ever-growing, permanent history.
And finally, T for tamper-resistant. This is where the magic of the chain really comes in. Each new block of transactions is cryptographically sealed to the one before it, creating a chain. If anyone, anywhere, tried to alter even one tiny piece of data in an old block, it would instantly shatter that cryptographic seal, and the entire network would immediately reject it as a fake. It's incredibly secure.
Okay, so we've got the acid model and the salt model. Now let's put them side by side to really see how they stack up against each other.
Now this table, this is where it all just clicks into place. Look at control, one boss versus a whole network of peers. Look at mutability. One is designed to be edited, the other is designed to be unchangeable or immutable. But the absolute killer difference is that last row, the trust model. In a traditional system, you have to trust an institution, a company, a person. With blockchain, you don't trust a person, you trust the protocol, you trust the math and the code itself.
And that really is the headline here. If you remember one thing, it's this. It all comes back to that one core idea, decentralization. By getting rid of the need for a single central gatekeeper, blockchain completely changes the rules of the game.
Okay, so they're different. Cool. But so what? Why does any of this actually matter? When would you ever choose this new model over the database that we know and love? Let's get into the so what.
Let's use a real-world example, managing a supply chain. Imagine you're trying to track, say, a shipment of coffee beans from the farm in Colombia to the shipper, to the roaster, and finally to your local coffee shop. You've got all these different companies that have to share information, but they don't fully trust each other. How can you guarantee that the data everyone is seeing is real and hasn't been faked?
Well, this is a perfect job for a blockchain. Its immutability means you can create a permanent, counterfeit-proof history for that batch of coffee. Its transparency means everyone from the farmer to you, the customer, can see its entire journey. And because it's decentralized, no single company can go in and secretly change the records to hide a mistake or cut corners. You're literally building trust into the system.
But, and you knew there was a but coming, this new model comes with some serious trade-offs. Just look at this. A centralized system like Visa can process tens of thousands of transactions every single second. Bitcoin, as a public blockchain, can handle about 7. That's a massive difference. And it's because that whole process of getting everyone on the network to agree takes time and a ton of computing power.
So here's the most important point. Blockchain isn't universally better than a database. That's the wrong way to look at it. They're different tools for different jobs. If you need lightning-fast speed for your company's internal payroll system, a traditional database is absolutely the right choice. But if you need bulletproof trust and transparency between parties that don't trust each other, well then, blockchain is the tool you reach for.
So, where does this all leave us? What we're witnessing here isn't just a simple technology upgrade. This really represents a new horizon for how we establish trust in a digital world.
When you strip everything else away, the most revolutionary idea here is that blockchain technology removes the need for a trusted middleman. The bank, the government, the central company. Blockchain offers us a way to coordinate and agree on things without them.
I mean, just think about what a monumental shift that is. We are moving from a world where we have to place our faith in institutions and the people running them, to a new world where we can trust an open, automated, and shared protocol that is controlled by no one and visible to everyone. We are, in a very real sense, trusting math.
And that leads us to one final, really powerful question. We've seen that this technology gives us a new way to trust our data. So if we can successfully decentralize trust, what other parts of our world could be transformed next? Now that's something worth thinking about. Thanks for joining me.